we're just going to do 7b. 7a is going to be done similarly, but 7a is significantly easier, I think. So 7b, we first need to decide, we're going to write it in sigma notation, but we first need to decide if this is arithmetic or geometric. So we need to decide, is it an adding pattern that's going on, or is it a multiplication pattern that's going on? Well, to check that, we can look between the terms, and we can say, if I take that term and I want to see, did I add something to this to get that? Well, I can take that and subtract this and see what that is, and see if it's the same as taking that and subtracting that. If it's a multiplying pattern, then I'm going to take that and divide it by that to see if I get the same thing as if I have that divided by that. So to see if I'm looking for an arithmetic sequence, I can take the 5 over 6 and I can subtract 5 over 4, and I get that number, and I'm going to do that. That was that difference, and now I'm going to do it again to see if it's the same thing or not. So 5 over 9, subtract 5 over 6, and I get different things there. So this is indicating it's not arithmetic. So what it is geometric. So I'm going to take 5 over 6, I'm going to divide it by 5 over 4, and that's 2/3. So I evidently multiplied by 2/3. I took 5 over 4 and I multiplied it by 2/3 to get 5 over 6. Now I'm going to see if I did the same thing this way. I'm going to take 5 over 9, and I'll divide it by 5 over 6. And again, you see that you get 2/3 again. So evidently you multiplied by 2/3 to get from here to here. And you can always check that again. You can do 5 over 4 times 2 over 3, if I do it right. And you can see that that does give you 5 over 6, and you could do that over and over again. So this is geometric, and so I've determined that r is 2/3. So that's going to be important, because when I do my sigma notation, I'm going to start with I equals 1. I'm going to have to figure out what term number this is. I'm starting with the first term, and I'm going to go to the nth term here, but I need to figure out what number that is. I'll do that in a minute. But then what I'm adding up here in my sigma notation is going to be the explicit formula. And so to know that, I of course have to know what r is. So the explicit formula for a geometric sequence is a sub n equals a sub 1 r to the n minus 1. So it's going to be 5 over 4 is my a sub 1. My r value is going to be 2/3, and then it's going to be to the n minus 1, but I'm using the letter I here. So it's going to be I minus 1. So the only thing I have left to figure out is how many times do I have to do this. I'm doing this, and I'm starting at 1, and I'm going ... That's telling me I don't know how many it is, some amount of number between here and here. I do know that this is a sub n. This term is a sub n, and so I want to figure out what n is. So I'm going to say a sub n equals a sub 1 r to the n minus 1. So 40 over 243 equals a sub 1. My r value is 2/3 to the n minus 1, and I need to solve this for n. Now we did this in the last unit. This is an exponential, and my variable is in the exponential. I'm going to end up using a logarithm to do this. But first I need to isolate this. So I need to get rid of this 5 over 4, so I'm going to multiply by 4 over 5. So 40 over 243 times 4 over 5. And that gives me, so now I'm going to come down here so I have some space. I have 32 over 243 equals 2/3 to the n minus 1. So there are a couple ways you can do this. You can equate these bases to make them both a 2/3, or you can take the logarithm, and you could do log base 2/3 of 32 over 243 equals n minus 1. So you could put that in your calculator and then just add 1. Or you can equate these bases. So this is method 1 and this is method 2. You probably don't recognize 243 as 3 to some power, but you might recognize 2. 2 to the 5th is the same thing as 32. And if you take 3 to the 5th, you'll get 243. So 2 to the 5th and 3 to the 5th. And so this is really just 2/3 to the 5th equals 2/3 to the n minus 1. And so 5 equals n minus 1, and so 6 equals n. So that's the number that goes right here. So I'm starting at 1, and I'm doing it 6 times. So this is the first term, second term, third term. Evidently, there were only 2 other terms in between here and this one. That was the 6th term. That's what I just determined from doing all of this.